Hi, hello, welcome to this is your IR Design Expert channel. Whole cylinder, 4 piston, single connecting rod with use of how it is work, how it is make animation, mechanical parameters will be given. Everything will be seen detailed. This video. This is the first time you will come in my channel. Please subscribe and click a bell icon. This is what continuously update our videos to be make a notification. So part number 1, engine block. Click a sketch and front plane and select a rectangular plate. The side thickness is 130. The 1315 and make a center line. Okay. And draw the circle. So based on randomly we'll give. After that we'll give a detailed dimension. We'll fix on the correct dimension. We will rotate. First thing the 60 diameter 60. The same thing is make equal for all the 4 circles. It is using for constraints. All 4 is equal. Click equal is automatically coming from equal dimension for all the circles. First thing in between distance for first circle to the side plane side surface, so 45, and then the second circle is 75, third one is 75, and then this is also 75, 25. Okay, and automatically the last one is 45, totally 315, also automatically 45. First going to extrude. The plate thickness is the cylinder block. This is a cylinder block thickness is 152. Okay, to make a cover the top surface. Convert it is using to make the edge lines to be make converts, and then make a thickness of 10 mm. Okay. So completed. Inner side is cylinder, 4 cylinders are available. Okay, first part is completed. We going to save. Engine block. Oh, the second part number 2, crankcase. Open sketch, front plane, draw the circle and draw the another one circle to give a dimension of outer circle is 50 and the inner one is 30. Okay, going to make a center line. This one is outer surface. One side surface you can make automatically. It should be mirror for the next surface. You will draw the crankcase. This is a bottom case. Here it is locating on a crank shaft. Dimension of this thickness, this height is. First we are going to trim the remaining excess surface. this is for this point to this point, top thickness. Okay, this one is 52 and this thickness is 35 and the bottom thickness is 86. Diameter is 86. This top thickness is 65. Okay. We are going to extrude. Select the inner. Okay, this was mid plane. Okay, mid plane can extend 20 mm thickness. Okay. Now again going to select the same sketch. The thickness is 10. The wall thickness is 10. Okay. Now we're going to make a datum plane of the center, the one side of the surface to another side of the surface. The total distance is 315 is the total engine block distance. So you can divide by 2, 157.5 mm thickness. So we can mirror the plane. The boundaries mirror. You can select entire boundary to make a mirror. Hidden the surface and the datum plane. And make a next sketch. Now we can outer edges you can extend up to the next surfaces. We are going to draw now. It is using two converts for edges. Okay. Now going to offset for this one. So going to inner 3 mm, reverse. Okay. We're going to save the crankcase. Okay, next part number 3, piston. Draw the sketch and break the datum plane and draw the center line. This piston is now we're going to draw using of a revolve command to make a 3 piston rings. First one, draw the lines approximately 2 pressure rings, 1 oil ring should be make it. So we will make a 3 guide way. The center distance 30. The total piston diameter is 60, so center distance is 30. This one is 5, and groove is 3, again 5, again 3, 5, now the thickness of the groove is 3. Okay, no problem. Okay, it's completed. This projection is to make a 3-point arc. The diameter is 60, and this thickness is 5, and now going to using of the command of offset. One mm thickness. Going to join the two lines, offset 2 lines. Now going to revolve the entire sketch. You can revolve based on this axis. Okay, fine. The mission is completed. Now we can make a hole of pin. Pin is locating on the piston. Okay, we can draw the circle with the variance of the center line. Draw the center line to measure the dimension of top to the circle center. And the bottom cut section, you can draw the cut section. Maybe select a 3-point arc. You can make a symmetric. This point, and center one. Make a symmetric. You can close the arc. We are going to measure the dimension. Radius of this. The bottom length is 40. Going to exit sketch, draw the extrude cut. This is for entire two surface, so through all for both surface. Mid plane. Okay, to extend both surface, to cut the this is completed for piston. Part number 4, pin. So then draw the sketch, like the sketch, front plane. To draw the circle diameter is already we will given make a hole. To make a hole is 13. To extrude, make a thickness. To click thickness, the entire pin is the hollow pin. So we make a hollow pin. 58 total is 60 mm piston. Totally the 68. This is center mid plane, and then save pin. Part number 5, crankshaft. Select part, sketch front plane, draw the circle, draw another one circle, and draw the center line. To make another one circle, this is for crank, so many circles are draw, and to make finally we will connect. Make a dimension for first one 35, the next one is 30, and then in between distance is 50. This one is 35. The inner, this is for the crankshaft, 30. And now going to connect the circles, extend and to be connected. Now going to extend up to the circle. Okay, now going to mirror the side edges. Okay, I'm going to trim the excess lines. Okay. Okay, this coming is structure. Make a radius of 10 and another one fillet. This is 5. Okay. Now the coming the structure of crank shaft. Okay. Exit sketch. I'm going to extrude. To select the part by part, many number of sketch we can draw, so we can select the part by part. I'm going to select the same sketch. Go to sketch on it. Inner one. This is for here. It is locating on connecting dot is locating here. To select the inner one is to extend up to 40. Now going to extend this one. This one is crankcase to be connected here. 50. Again extrude the same. Select the surface, extrude, select. Now going to select the convert to be automatically converted for which surface we want to draw. Automatically it will be converted. It's very easy, it's the way. Mirror in the sense we can draw the center plane, there's no need for that. Make a draw for next crank, the center shaft is also to make a convert using convert entities. Convert, make a extrude. Now this surface, select this extrude, that will select the convert entities, this be converted. Now select the entire sketch and going to rotate entities. Okay, we select a center point. So keep relation should be unpick. That is what the sketch should be rotated. It's very important. So how much degree can rotate? Totally 180 degree should be converted. Rotated. Okay. Going to extrude 10 mm. Same on next one. Next is cylinder locating here. The same one should be created for here. So we can draw the circle for the center one. To select, diameter is 30. Going to extrude 40. Going to check this. This is also 40. Now again the same method to make convert entities using to convert the next crank and select the sketch. Now converted for this one. .5. Why 7.5? Will now we can mirror the entire setup. That is what we will select. Given 7.5. So boundary mirror should be converted for entire setup. Okay. Okay, it is automatically coming based on this surface. It is automatically mirror. Okay. Now we can see that it's coming, but cannot be merged into solid body. Should be re-edit to merge two surfaces. Okay, you can merge. Now we can complete it for the entire crankshaft. should be saved. Crankshaft. Okay, part number 6, connecting rod, top portion. Select the part, draw sketch, select front plane, draw the center line. Okay, we can select the circle. This is a smaller end. And draw the one smaller circle. The same method you can follow. So easily draw the connecting rod. The outer diameter is 18. The inner diameter is 14. This one is 10. This outer diameter is 66. The inner one is 60. And we can connect the entire circles. The two circles distance is 135. This is make a center, use of the center point. 135 divided by 2. 135 divided by 2. Okay, make a center. These two circles distance is 30. Okay, this is extend. This line is connected for up to the center one. To make a smaller projection is there. So we give a projections and then it should be connected for center point. Okay. I'm going to select the delete, make a 3-point arc. To make arc, the arc is one tangent, and this arc diameter, the arc radius is 190. The piece distance 25. The top distance is 5. The thickness is 5 to the center one. So 35, 30. Okay. I'm going to trim the excess lines. Now we can undo to draw the center line to be extended up to the next surface. Some tangent approximately first you can draw, after that we will give a dimension for that. Okay. Now I'm going to make a radius. This radius for 5. So okay. Select the center one to trim these excess lines. Now I'm going to mirror the entire line. I'm going to click a mirror, select all the lines and select the mirror. Okay, it's becoming. Now I'm going to select the interior angle 6. Okay. These entire lines to be make a mirror. So this is center line. Okay. Okay, it's becoming to remove an excess arcs. Now completed. Exit sketch. Going to extrude. Select outer one, inner one, outer surface, and then this inner one. Now going to using of same sketch. And outer circle, some extension is, we want some extension. This extension is 20 to make a mid plane. To modify the extrude mid plane. Okay, this also modify for mid plane. Okay, again go for a sketch. The same sketch should be used to extend. Okay. Okay, it's perfectly made it mid plane. So 20. Okay. Go to extrude for the outer edges, the interior smaller thickness. So cannot be draw the sketch. Going to sketch, no need. Just want to thick the surface. Thickness is only for we need the 3 mm. So it automatically coming for smaller rib. It is very simple. Otherwise we can draw the entire, select the entire component entities and make offset. No need for that. To select the mid plane, it's very easily. We will got the smaller thickness of the rib. The 15 mm thickness is completed. Okay, so connecting our top section should be completed. We'll do height and then make a hole. Make a hole of this. Now going to select the outer edges, convert entities. Okay, offset 2 mm thickness. This converted. Okay, to join the complete, close the 2 offset lines. Extrude. Five mm thickness. Now it's a 3 mm thickness. Now going to mirror the end. This rib is mirror the top plane. Okay, again go for a mirror. Delete this plane. Again go for a mirror. Select 2 ribs. Or the center one. Okay. Top plane. Not a top plane, it's a front plane. Selecting a front plane. Okay. Okay, it's became. Now it's completed. Okay, it's behind. Make a connection of connecting rod top and connecting rod bottom. Both the connecting rod should be coupled with a single pin. Listen it. This is for entire thing is based on the single sketch. So very easy draw the one method. We are going to draw the whole of connecting rod and bottom connecting rod and top connecting rod location. This hole is based on that. This hole only connecting for top connecting rod and bottom connecting rod. The circle diameter is 7 diameter. The top surface to the circle diameter is 12. Circle length is 12. Part number 7, connecting rod bottom portion. Sketch front plane. Select the center line. Okay. And draw the eye section of this connecting rod portion. You can draw one side, automatically you can mirror and make a revolve easily. The top length is 7. This thickness is 8, and then this length is inner thickness is 5, and bottom one is 10. Length is 10. The entire length is 25. Okay, now going to mirror. Select the axis. Okay, I'm going to trim the interior layer lines. Okay, and the center distance. Based on this center axis, we can revolve this eye section. Okay, fully constrained. Exit sketch. Revolve. This revolve is only mid plane and 180 degree. Okay, we're going to draw the circle. Select this surface. Select the sketch and draw here. This circle is connected for top connecting rod. This is for 17. This is coming interior, so we can modify that. Okay, this time to 7. We can draw the both circles. Okay, extrude. So very interior, so we can draw. Okay, the hole is 4 mm, but the projection is 9 mm. So we can draw the 9 mm projection. Okay, and interior hole is 7. Okay, extrude cut. This is going to mirror based on a front plane. Now it's very coming interior like that, so we can modify that. The top surface to the circle length is only for 12 mm. Okay, regenerate. Okay, regenerate is completed. The same modification is coming. To revolve round the edges. Great. Okay. Part number 8, pin number 2. Onto the edge, front plane. Select the circle. Okay, it's very easy to draw the revolve command. The pin head is also available, so we can draw the revolve command very easiest way. Pin bottom, so pin head. Okay, we know that the pin bottom is only totally 7, but in half of the portion shows 3.5. The total length is 70. The pin head 5. This is 9, so 4.5. Okay. Now we're going to revolve. Okay, save. Pin 2. Finally, we're going to assemble. Final assembly. Select the assembly. First, going to select the rigid one. Select engine block. Okay. And select next one, crankcase. So rotate. Okay. This way we can locate it there. Going to mat, top surface to top surface, and this side surface. Okay, bottom back surface to back surface. Now it is assembled for center or make some alignment, I don't know. So that is what using advanced command of width. This is first you have to select the both top surface and select the bottom one. So automatically align the center. You can make a center axis. Both components should be assembled in single center. This is what we are using the width command. We can re-modify that. Okay, fillet mirror. It is not coming in perfect manner, so we can re-modify the outer surface. 86. The same 86 we can reduce the projections. Okay, and delete now. Some of the features is also delete. Okay, we can re-modify that, no problem. We can delete the entire thing. I'm going to offset. Three. Okay. Now with this sketch. Oh, now we complete the sketch. Okay, we can complete. Using the extend command. Make a trim. Okay. If this is automatically coming for final case. Save and then make assembly. Now going to mirror. Okay, perfectly coming case. Final assembly. Both of them are transparent view. Select the piston, connecting rod and crankshaft, pin, everything. First one, second one, just for a click, one by one. Okay. This cylinder surface first to hide any one of the component. Bottom component we can first to hide. Crankcase to be hide. Now going to assemble. Select the mat. Piston concentricity. And then select the catia pin. Now we can change the catia pin is locating on some projection. That is what open. So right plane, using the right plane, make a sketch. Draw the circle center. This is for 16. Okay. I'm going to extrude. So up to the center circle, you can modify the offset. An offset command is there. This offset command is using to some distance of offset. How much distance we can given? No problem. Up to the surface, the center one. But offset distance is 15. Okay. Now it is completely easily find out. Or if we can draw the other on data plane, very difficult to draw. So it's a very simple one. I'm going to mirror right plane. Okay. And then make a roundness. So 5 mm. It's also 5 mm. Okay. I'm going to save. Again go for assembly. The catia pin is locating on the concentricity of piston, and then the same one, advanced mat. Select the width command. First one, top surface, both the ends. We can identify the center axis. Now which component we can centrally locate it, and select another one. Otherwise, generally we can make using for unhide the data plane of both the component and select the center data plane. It's very difficult. It's a very simple one. This command is very useful for that. And select connecting rod. So to rotate. Okay. This also same the width command, advanced mat. The connecting rod is locating on the center one. The two side surfaces. Connecting rod center is identified. And the next one, the piston to piston center surface automatically mapped centrally. Okay, and then locating on the bottom connecting rod. Let's go to mate. Rotate the particular location, and then now we're going to drag the photo, click and drag the component. Drag the component. Okay. Just you have to click left click and drag the component. Okay, side edges and select the center hole and the bottom surface, bottom matting surface. Okay, it should be assembled. Now fix the pin. Click the pin surface and the connecting rod inner surface. It should be locating on here. Again you go for a so to rotate the pin. Select the outer surface and the inner surface of the connecting rod. You can edit last mat, concentricity. You should flick. Okay. Okay. And this top surface to interior bottom surface. Okay, perfectly matte. Composition is somewhat bigger. You can reduce the length of the pin. $60. Okay. Okay, it should be perfectly mated for the surface. Again, it should be rotated. Unhide the crankcase. Unhide the engine block. I'm going to make the crankshaft and side surface. This using to width command, advanced mat width command. This also locating the center of the place. This surface to this surface center, and the next one crankshaft center. Both of them fixing in center of the place. Okay. Transparent. I'm going to assemble the connecting rod bottom to crankshaft. Okay, hide the crankcase. It is also locating on center of the place, so we can use the advanced mat command. inner surfaces. Okay. Okay, it should be perfectly moving piston, first piston. Going to select the piston connecting rod and pin, joint pin. First one, second one, third one. Again go for the same method. Piston, second piston, concentricity mated, and then locating for the joint pin. Okay, and center of the place using for the width command. Okay, the center of the identify the center of the joint pin and fixing in center of the piston. Okay. The same method, you can assemble the connecting rod is also going to rotate. Right. Okay, and top surface too. Okay. Okay, should be completed. Now going to fix this connecting rod bottom face and this location. This is using to advanced width command. Send it. This advanced width command is most useful for this of the complicated assembly session. Easy to locate the center of the component. Center of the particular location, everything should be identified very easily. We are going to connect the piston. Okay, first going to mat. Going to click the concentricity on this one. Okay, can assemble. Okay, just go to drag it. Left click and drag it very easily. The same location, you can fix it very easy for assembly, or otherwise it's very difficult. This connecting rod pin is also. Just should right click and drag many number of times. You can copy this component. Next one, next third cylinder. This curtain pin is also connected. First would exit mat. Mat. Select both surfaces. Now going to select the width command. Advanced width. Select curtain pin center, and then now going to select the piston center. Okay, should be located, and then I'm going to connect the connecting rod. Okay. Control plus right click, left click, it should be copy. Just you have to right click in the sense it should be moving the component. Okay, mat is over, concentration is over, and then mat the connecting rod. Now going to advanced mat with command. This surface to this surface. Okay. I'm going to fix the smaller end of the connecting rod. Select mat. So to adjust it, select the outer surface and select the inner surface of the internal connecting rod. Okay. To mat connecting rod pin. This surface to this surface. Okay. This will be fixed. Click, press Control. Then copy another one component. Top surface to this top surface. Connecting rod bottom and top surface. Okay. I want to flick last one. I want to flick and then top surface to top surface. Same one. Exit mat. Click, left click and drag. Click plus Control command. Okay. And select the top surface to this bottom surface. Okay, the last piston I'm going to assemble. Okay, just click, Control plus right click, just go to drag, we copy, mat, To make a sub-assembly is also possible, no problem. Sub-assembly in the sense we can assemble this connecting rod, piston, everything should be already assembled. Another one assembly, we can use of that, no problem. It's very simplest way. Bottom surface and select it, and another one pin. Inner surface and then inner surface. Okay. Connect the gauge pin. Okay, concentricity is completed. Now we'll fix the advanced mat. Use of with command. First we'll select the piston center, and then gauge pin now. Side surfaces. Okay, it's fixed. Now we're going to fix the gauge pin to piston. We're going to fix piston to the cylinder. Okay. Now we're going to assemble internal smaller end of the piston, connecting rod. Advanced mat with both end of the piston surfaces, and select mat surface. These are mat references. Okay. Now we're going to assemble the bigger end. So we'll drag it. Okay. Going to assemble the bigger end. Connected. The assembly is completed. Now unhide the crankcase. Entire assembly session is saved. Final assembly. Okay. So motion study and analysis. We're going to fix the motor. The crankshaft, which will be guided with the crankcase. The constant speed. The speed is only for 225 RPM. That is what we are viewing purpose very easily. Okay, excellent. It should be animated. Extend the seconds up to 14 seconds. And calculated that. Okay. Okay. I'm going to give a render appearances of each and every component. Okay. Hide the entire surfaces. New motion study. You will give a motor. To 25 RPM. Okay. Let's be moving for up to 10 seconds. I'm going to calculate. Okay, it's animating perfectly only for the piston cylinder, sorry, piston connecting rod and pins. 1 to 1.5. I'm going to give appearances. Before that, this engine block to make a cut section, half of the cut section, easily viewing the interior piston cylinder movement. So that is what we will make a cut section of center of the axis to make a cut section. Okay, the extrude cut should be cutted. Save. Okay, now I'm going to give a color. So steel, blasted steel. Okay, save. And the next one, final assembly, going to see there. Okay, the same method we can see the cut the crankcase is also. The mirror is you can just sort of drag it. Okay, going to give appearances. Brass, metal. Okay, save. See the final assembly. Okay, nice. And give a piston. Piston appearances. So brass metal, copper metal. Brass metal. Bronze metal. Okay. And then connecting rod top. This is appearance to be give. Sandblasted one. Connecting rod bottom. Okay, this is iron. It's a crankshaft. Okay. Okay, this is a copper. We're going to give appearances of the giant pin. Brass metal. Give a fillet of the outer edges. So 5 mm. 2 mm is enough. 1 mm. Okay, it is completed. Now this one. Okay. Final assembly. So next thing I can show you will do a motor for crankshaft. Okay, this RPM is the same 25. Okay, up to 10 seconds. You can calculate it. Okay, viewing very nicely. Appearances are creating a good look for your design. I'm going to give a background color. It will be very brightness of the component. Oh, wow, excellent. It will be very clear and brightness and lighting of the appearances. That is what will give a background color. Okay, finally, you can save your final assembly animation. You can save. So you can drag it or okay, save. Okay, saving. Okay, I'm going to capture the entire animations we will convert it for video. Thank you for watching our design expert channel. Subscribe our channel.